Okay, I'm Carl Washburn, and today we're going to be talking about fluids, lines, and fittings. We're going to discuss hoses, we're going to discuss rigid lines, we're going to talk about where we're going to use them and how you're going to be able to identify and tell the difference between them. You should, by the time we finish this module, be able to distinguish between a rigid line, a type of rigid line, a hose, a hydraulic flexible hose, where you would use it, and a type of fluids that that hose is designed to carry. We'll also be looking at some obvious damages that you could find on a hose, how you could repair it, or if you're going to have to replace the line or the hose assembly. Let's start off looking at aircraft fluid lines, and let's look over here in the picture, and you're going to see here way off that we've got some rigid lines on that particular engine. Notice a rigid line is going to be installed in an area where there's very little movement and very little vibration. And then if you notice here, we've got some flexible hoses. Notice those are installed on areas such as reciprocating engines, something that's going to shift back and forth. That flexible hose is going to allow us the flexibility to have something move, whereas a rigid line is just that. It's rigid. And if we try to move a component that's attached to a rigid line, we're going to end up with more damage. Why metal lines are used? Metal lines are used on stationary objects, and we just talked about that. Very reliable, very rigid, and we have to have a way to get fluids and gases from one point to another point. So the rigid line is typically the easiest way to move that fluid from one part of the airplane to the next, from the hydraulic pump out to the aileron actuator, or from the fuel pump up to the engine. Metal lines are going to be used for long, straight runs where we don't have a whole lot of bends. If you have to have a lot of bends, or we have something that's flexible and moving, again, we're not going to use a rigid line. We're going to want to go ahead and use a flexible hose. We could be using these rigid lines to move coolant. Yeah, we have coolant in airplanes. What about fuel? We could be using fuel. Some fuel lines are going to be flexible hoses, but quite often you're going to see rigid lines used to haul fuel, move it from one end to another. Oxygen systems, so the pilot and the passengers can breathe. We'll be using the rigid lines for transporting oxygen, high pressure oxygen from the oxygen system to where the user is going to be using it. The instruments, not necessarily high pressure. These are going to be sensing low pressure, sensing static pressure. So these will be low pressure lines. And then hydraulic lines. We talked about the hydraulic system. We need to get the hydraulic pressure from the hydraulic pump to the flight controls, or to the landing gear, or to the gear doors, or to the flaps, the flight controls that we actually have to actuate in flight. So that's the purpose. That's where we're going to be finding our rigid lines used in. Flexible hoses, on the other hand, we want to use those where the rigid line isn't going to work. We're going to use the flexible hose. Say we have that rigid line that leaves the pump, goes all the way up to almost where that flight control actuator is at, but that flight control actuator is going to move up and down as the ailerons move up and down. Or maybe in the landing gear system, as that landing gear system goes up and down. Or maybe in the brake system, as that landing gear strut extends and collapses, we need to still be able to get hydraulic pressure to the landing gear, to the brakes, to the flight controls. So the rigid line will go all the way up to a point and stop, and then we'll use that flexible hose to operate a hydraulic mechanism that moves and isn't rigid. Areas that are high vibration, reciprocating engines that as you accelerate, the torque of the engine causes it to twist. Areas like that, that's where we're going to find those flexible hoses at. If you find a damaged hose, can we repair it? We'll research the AC-43. We'll look and see what the advisory circular tells us. What are the repair limitations on the hose? Is it easier to repair the hose, or is it easier just to go ahead and replace the hose? When we replace the hose, what do we replace the hose or the line with? Are we going to manufacture it ourselves, or fabricate a brand new hose, or do we get with the manufacturer and order an original replacement? If we're going to fabricate the line, we need to make sure that we're fabricating the line with the same material that the original line was made of. Otherwise, we're going to alter the airplane, and we know we can't alter the aircraft. Some common damage problems that we find with airplanes. If you look at the top one, you'll see that it's vibrated. And what happened here is maybe the line was too long. Maybe something was vibrating, rubbing against it, and over time you can see it's just kind of wore through the line, a bit extensive. Maybe it was an area we couldn't see. And then we look at the bottom line, another damage in the bottom line that we see. Again, it could be vibration. Maybe somebody was in there working and banged it with a wrench or got it a little bit too close or dropped something on it. So as you're performing your inspections, these are some of the areas that we want to go ahead and look at in tubes. And I know we're going to cover this in a little bit, but you know, the heel of a tube where you see that top, no marks, no mars, no dings. That material is already stretched to its limit, so we cannot have any damage in the heel of a bend. Another common cause for tube error, if you notice the flare, see how the flare is kind of coned in a little bit? Maybe when the individual installed this, he might have had a piece of sand or dirt or some kind of FAA debris was actually caught between the flare sleeve and the flare itself. And when the wrench was tightened up and the fitting was tightened, it actually caused the flare to actually mushroom in, which would cause a leak. And that's how this leak would, that's how this would be found. And here's another dent. Notice the damage here. That's a straight line. So we're allowed some damage in this area, but looking at that, my guess is we've probably gone beyond the allowable limits. How does this damage happen? Again, maybe somebody hit it with a wrench. It might have been tight working area where you were in working or somebody else was in working. Damage like this, not real common, but certainly something we have to look for on a regular basis. Fluid lines. Just a few points. Fluid lines are made of metal. They're rigid tubes used for stationary locations. We discussed oil. We didn't. Hydraulic fluid, oil, fuel, oxygen. Not only are these lines going to carry different materials, but it's also going to determine the temperature of the fluid that's going to be moved. Obviously, fuel is going to be significantly cooler than hydraulic fluid. It's going to determine the pressure. Your instrument lines are going to be very low pressure, whereas your hydraulic lines are going to be high pressure, 3,000 psi. The flexible hoses, again, still can handle the same pressure, but we're going to use those in a area where we have excessive vibration or we have a component that's moving. Common causes for tubing failure, more often than not, is abuse. One way or the other. We didn't take care of it. Maybe we didn't perform a good inspection. Maybe a clamp came loose somewhere. And then the repair of the line. Again, we'll follow what the advisory circular, the AC-43, tells us we do. Sometimes if we have a scratch or a dent, we can do some tubing repair. Sometimes it's just easier to replace the line. Remember, if you manufacture a line to replace what's there, it's your responsibility to do the pressure test. And when we manufacture and we do that pressure test, we're going to pressure test that line according to the AC-43 at 1.5 times the system operating pressure. So if you're replacing a hydraulic line on a 3,000 psi hydraulic system, you have to test that line to 4,500 psi. And unless you've got the equipment to do it, you're better off just to go ahead and buy a new line and let somebody else pressure test it before you put it on.